Mathematics has always been more than just a subject for me. It's a passion, a way of seeing the world through the lens of logic and patterns. When I discovered financial mathematics, I realized that this field is not just about managing money, it's also about understanding the intricate dance of numbers that govern the financial world. Whether maybe I'm saving for my first car, let's say, or planning a dream vacation, or even that I am contemplating for my financial goals. In all of these, understanding the basics of how money works is crucial. And here, financial mathematics offers a fascinating challenge that blends my love for numbers with practical real world applications. It's not just about making informed decisions, it's about the joy of unraveling the mysteries within the numbers. We often see the words financial mathematics that might have once conjured up images of dense textbooks and complex formulas that seemed impossible to decipher. But as I've come to realize, it's not about diving straight into the deep end. Instead, it's about taking a step back and exploring the foundation, the building blocks of financial mathematics that, once understood, can make the more complex topics seem a lot less intimidating. And that's what we'll be doing in today's video. So firstly, at the heart of financial mathematics is the concept of monetary value. This isn't just about how much money I have in my wallet, though that's certainly part of it. So monetary value here refers to the financial worth of something. And this worth isn't static. It fluctuates over time due to various factors. For instance, I once bought a shiny new smartphone, excited about all its features. But soon I realized that the moment that I walked out of the store, it started to lose value. Why? Because of depreciation, a term that I've come to understand as the process where things get worn out, outdated, or just plain less desirable over time. Depreciation is a key concept in financial mathematics because it reminds me that not all assets are created equal, and the value of my possessions can change dramatically. For example, like here is the value of smartphone decreasing steadily. Next, I encountered the concept of interest, which can both be a friend and a foe depending on the side of the coin that I'm on. So looking at this drawing of mine, it is noticeable that this is a dollar bill. But what does it symbolize? Well, the dollar bill here is split into smaller pieces to represent paying interest, then multiplying to represent earned interest. So, like when I borrowed money for my studies, I knew that I'd have to pay back more than I initially received. And this extra amount was called interest, a representation of the growth of money over time. It's like the bank's way of saying, thanks for the loan, now you pay me back with a little extra. However, on the flip side, when I started saving money in a bank account, with my dad's help, interest worked in my favor. The bank paid me the privilege of using the money, and over time my savings grew. Understanding how interest works became crucial for making smart financial decisions. Whether I was considering a loan or maybe planning to save, knowing how interest could affect my money turned out to be a vital part of my financial literacy. And then here's inflation. Just like it's like that sneaky friend who borrows my stuff and then forgets to return it. Inflation refers to the general increase in prices over time. And while it might seem harmless at first, it can have a significant impact on my purchasing power. What I could buy with 10,000 Vietnam dong today might be very different from what I could buy with that same amount of money years ago. Inflation is driven in part by banks charging interest here, then which leads to higher costs for goods and services, like this loaf of bread or gas. It's like a key concept in financial mathematics because it affects everything from how much I should save for the future to how I can manage my investments. Understanding inflation has helped me make more informed decisions about my finances, so I don't get caught off guard by rising prices. Like this bar graph here, where the cost of everyday items like bread here and gas steadily rises. Phew. And as I delved deeper into financial mathematics, I learned about the rates of change, often represented by the symbol I. The rate of change is essentially the speed at which a value changes, whether it's growing or declining. This is usually expressed as a percentage and is an essential tool in financial mathematics. For example, if I'm tracking the growth of my savings or the depreciation of an asset, the rate of change gives me a clear visual of how quickly those values are shifting. Or consider this speedometer. It is rapidly increasing if I change this from here to here, with percentages flashing by, showing how fast something is growing or sinking. And understanding the rate of change became crucial because it helps me to predict future outcomes, like whether I'm planning for a long-term investment or I'm just trying to figure out how long my car will hold its value. Knowing the rate at which things change provide valuable insights. And finally, I encountered the concepts of simple and compound growth and decay. I began to think of these as the tortoise and the hare in the race of financial mathematics. Like simple growth or decay is like the tortoise, steady, consistent, and predictable. It involves a constant increase or decrease over time, making it easy to calculate and understand. Compound growth or decay, on the other hand, is like the hare here, fast, dynamic, and a little bit more complicated. Compound growth or decay takes into account the changing value over time, meaning the rate is applied not just to the original amount, but to the accumulated value. This is why my savings can grow exponentially over time if I leave them untouched, or why debt can spiral out of control if not managed properly. And understanding the difference between simple and compound and growth and decay became essential for making sound financial decisions. It's the difference between earning a little extra on my investments and watching them grow into something substantial over time. And all of this concept, if we can grasp them, we make smart financial decisions. Smart financial decisions. I'm just phrasing it like that. For me, financial mathematics isn't just a tool. It's like a playground for my passion for numbers. Every concept from the fundamental idea of monetary value to the complexities of compound growth offers an opportunity to dive deeper into the world of mathematics. Understanding these principles allows me to navigate financial landscape with confidence, not just because I have the knowledge, but also because I genuinely enjoy the process. And in the realm of financial mathematics, each calculation is like a new puzzle to solve. Each formula, a key to unlocking deeper insights. And for someone who loves math as much as I do, there's nothing more satisfying than seeing how the numbers can work in my favor. And remember, in the world of financial mathematics, knowledge isn't just power, it's money. Thank you.